All right, everybody, how you doing? I'm your man, John Wilson, and today, I'm all in.
You're doing a card trick.
Today we're going to finish up Module 5. We're going to do Module 5.3. We are going to figure out what exactly makes a relationship linear, and then we are going to talk about your homework. Now, as you can see here, I have a fancy new board. Everything is touchscreen, which means I don't need a stylus anymore, but I'll probably still use one. Woo! I'm erasing time and space itself.
Cool.
Let's just make this a little smaller because I don't think that I'll get much done if I'm writing everything that large. All right, so today we will understand how to contrast linear and nonlinear sets of bivariate data. Now that's a new big word there. Let's actually change this here. But don't let it throw you off. That simply means we're talking about data that contains two variables, which is something that we've been dealing with all along. We've always been dealing with the coordinate plane. We've always had a y and an x. Now we're just going to contrast what makes something linear, what makes something nonlinear. And the good thing is you already know how to do most of it. Then once we do that, we'll apply this to real-world situations and scenarios. Now, bivariate data is a set of data that is made up of two paired variables, once again, x and y. That's nothing new. If the relationship between the variables is linear, then the rate of change, also known as the slope, is, what do you think? What word do you think goes here? If it's linear, what word should go there? Not proportional is constant. If it's linear, the rate of change is constant. Now, if the graph or table or whatever shows a nonlinear relationship, then the rate of change between the pair of points will vary. So what we're looking to find out is if we have a constant rate of change in regards to our data points, because we're dealing with tables right now. If we have a constant rate of change between all of the different sets of data, then we have a linear relationship. If we do not have a constant rate of change, then we do not have a linear relationship. How do we do this? Something you already know. So we want to identify the rate of change between the first two sets of points. 3, 15, because that's my x, that's my y, and 9, 45. So these are just coordinate pairs. I have 3, 15, this is stuff we know how to do here, and I have 9, 45. To find the rate of change, remember that the rate of change, we find that the same way that we would find the slope, which means we can use the slope formula. My slope formula, of course, in case you forgot, is y2 minus y1 over x2 minus x1. We substitute in our values, and we determine our rate of change. So I'll show you how we do the first one, just in case you forgot how to do slope. I identify my y2, my x2, my y1, and my x1. So this is going to be my y2 because it's the larger of the y values. That makes this my x2, that's my y1, and that's my x1. Then I substitute these values into my formula. I'm going to have 45 minus 15 over 9 minus 3. Anybody can tell me what 45 minus 15 is?
30.
30, okay. And 9 minus 3 is? 6. And 30 divided by 6 is? 5. So the rate of change between the first two sets of points is 5. That doesn't mean I stop there. That means that now that I know the rate of change between the first two sets of points, I must find the rate of change between the second two sets of points. So I go again. I write out my coordinate pairs. What's my first set of coordinates going to be, Corey?
9, 45.
Good. Let's actually change the color here. 9, 45. And what's the other set?
21, 105.
21, 105. We can then substitute this into our formula and solve. So, Adriana, what am I going to write? I'll assume that you know what the y2 is.
105 minus 45.
105 minus 45 over 21 minus 9. What's 105 minus 45? Anybody want to help her out? 60, okay. And then 21 minus 9 is 12. And then just Adriana, just her. What's 60 divided by 12? 5. So do I have a constant rate of change here?
Yes.
Yes, the rate of change is constant as 5, which means that this is in fact a linear relationship. Found the rate of change between the first two, found the rate of change between the second two. They're the same. I have a constant rate of change, which means I have a slope, which means that this is a linear relationship. On the one below, what happened?
Did we read this?
You did learn this. You learned parts of it. Now we're going into more detail with linear and nonlinear. Thank you, and thank you. Emily, help me with this problem. We're going to find the rate of change between these sets of points and then these sets of points. So I'll assume that you know what the coordinate pairs are. I'll assume that you know what y2 and x2 and y1 and x1 is. Tell me what I'm going to write.
5, 30.
Those are my coordinate pairs. That's the first set. What's the next set?
And 8, 76.
8, 76. Good. So what is going into my formula?
Okay, 76 is your x, no, your y2.
This is my y2, which means that this is my
x2.
x2, this is my
y1.
and this is my
x1.
okay, and then substitute. What are we writing?
76 minus 30.
76 minus 30 over
8 minus 5.
8 minus 5. And what is 76 minus 30?
46.
Just Emily, please. 76 minus 30 is?
46.
46. And then what is 8 minus 5, Emily? 3. And you know what 46 divided by 3 is? It's going to be a repeating decimal, I'm going to say. Did I figure it out?
15, 3,
Yeah, 15.3 repeating. She was making a little bar notation symbol right there. 15.3 repeating. That's the rate of change between the first two sets of points. All right, Chris. Next two sets of points. What am I going to write as my coordinate pairs? 8, 76. And 14, 235. Okay. What's my y2, x2, y1?
235 is y2 and 14 is x2.
My y2, that makes that my x2, so this is my y1 and this is my x1. And then tell me, what am I writing?
235 minus 76 and 14 minus 8.
235. That's, all right, oh, let me fix that. Still getting used to the touch screen. So that's x1, and then we're going to have 235 minus 76 over 14 minus 8. You know what 235 minus 76 is?
159.
So we'll end up with 159 over 6. You know what that simplifies down to? Just 10.
26.5.
26.5. Do I have a constant rate of change here? No, I do not. The rate of change varies, which means the relationship is non-linear. So all you're trying to do is just find the rate of change, also known as the slope. See if it's constant. If it is, it's linear. If it's not constant, it is non. Thank you very much. Questions on this so far? Questions? Anybody have any questions? It's stuff that we've done before. We're just applying it to a different discipline. Let's try a couple more of these. Real quick. Speed it up a little bit. Let's go to Jennifer Gutierrez. What am I going to write?
Okay, you're gonna first put x on the ones and y on the x.
Good, that's my x, that's my y, okay.
And you're gonna use 0, 220.
Okay, so we're finding the rate of change between the first two, 0, 220, and then the other one is going to be
1, 240.
1, 240, okay. What goes into my slope formula? What am I going to write?
Y2 is 240 and
Okay, so 240 minus
220.
220, okay, and on the bottom?
1 minus 0.
1 minus 0. 240 minus 220 is 20. 1 minus 0 is 1. So my rate of change here, if I simplify it, is 20. Then let's do the second set of points here. What am I going to write now as my coordinate pair?
1 comma 240.
1 comma 240. And
2 comma 60.
2 comma 260.
Yeah.
Okay. 2 comma 260. Good. Now, what goes in the formula?
260 minus 240.
260 minus 240. And then, Vivi, what goes on the bottom?
Oh, 2 minus 1.
2 minus 1. Okay? 2 minus 1. 260 minus 240 is 20. 2 minus 1 is 1. So my rate of change here is 20. Do I have a constant rate of change, yes or no?
Yes.
Yes, I do, which means that this is, in fact, linear, and my constant rate of change is 20. 2 more examples. We really want to make sure this is driven home. It's also giving us extra practice on the slope. Cart left. This one right here. Oh, look at that. Blood splatters. Next time on The Walking Dead.
Or Scream Queens.
Or Scream Queens. Okay.
Yeah.
Kind of looks like the Halloween theme. Anyway, all right. Cart left. What are my first 2 coordinate pairs?
2 comma 8.
2 comma 8 and
3 comma 12.
good. We're finding the rate of change between those 2 sets of points. So we have 2 comma. It would help. Yeah, you can't. This thing is so sensitive. If you touch it at all, obviously if it's a touch screen, it starts writing marks everywhere. Okay. So you just tell me what goes in the formula.
12 minus 8.
12 minus 8 over
3 minus 2.
3 minus 2. What is 12 minus 8?
4.
4, and 3 minus 2 is 1, so this will equal 4. Okay. So we have one rate of change. We got to find the other one. Flash! Savior of the universe! Flash!
What?
We're getting a nice little chorus thing going on here. All right, Flash. What coordinate pairs am I using for this now?
3 comma 12 and 4 comma 15.
3 comma 12, 4 comma 15. Tell me what goes in the formula.
15 minus 12.
15 minus 12. Why 2 minus 1? 1. Okay, and then
4 minus 3.
4 minus 3. Okay, what is 15 minus 12?
3.
3, and 4 minus 3 is
1.
1, and that simplifies down to
3.
3. Do I have a constant rate of change here, yes or no? No, which means that this relationship is nonlinear, and my constant rate of change in A. No, don't say 0, because 0 is actually a constant rate of change. 0 would be if we had a graph that looked like that. That's 0.
You said not to put NA. You said to put varies.
Yeah.
What happened?
You said not to put NA. To put varies.
Varies?
Yeah.
Well, no, I'm just, now here's the thing. I said that would be if there was a rate of change, would be varied. I'm asking you if there's a constant rate of change.
Can you write nothing?
Well, you can write nothing, you can write NA, you can write D and E. If I was just asking you for this, look, if I was asking you for the rate of change, you could say varies. But I'm asking you if there is a constant rate of change. I have to remember with the touchscreen now, I can't even touch the board, or it's just super sensitive. So if I was asking for a rate of change, you could just put varies. But I'm asking you if there's a constant rate of change. Since there is not, you can just put NA, you could put nothing, you could put not available, you could put does not exist. But don't put 0 because that's 0. Oh, I mean, if it was a straight line, it would be 0. But you get the idea, right? All right. What's up? You want to help me with the last one? You sure? You're not going to mess it up, right? You want to help me with part of it, and you help me with the other part of it? Okay, so you help me with the first part, and she'll help me with the second part if she's not drinking her 5,000 ml of water. Okay, so.
You know that actually exists called the $1,000 watch.
You think so? $1,000 water?
I saw it.
That stuff better be
But
delicious.
it's like supernatural.
All right, Matthew, what do we got?
2 comma 100.
2 comma 100, okay.
And then 3 comma 150.
3 comma 150, okay. And what goes in the formula?
It goes 150 minus 100.
150 minus 100 over
And then 3 minus 2.
3 minus 2. What is 150 minus 100?
50 over 1.
50 over 1, which simplifies down to
50.
50. Okay, so we have one rate of change.
But do the other one or she doing one?
She's doing the other one. This young lady over here. Farama, What are my coordinates?
Okay, 3 and 150.
Okay, 3, 150.
And 6 comma 300.
6, 300. Okay. And
The
what am I writing?
is 300 minus 150.
300 minus 150. Okay.
6 minus 2.
6 minus 3. What's 300 minus 150? 150. And 6 minus 3 is 3, and that simplifies down to 50 over 1, or just 50. Do I have a constant rate of change here? Yes or no?
Yes.
Yes.
Yes, I do, which means this is linear. My constant rate of change is 50. Any questions on any of this? This is the long part of the lesson. Everything after this is pretty quick. Any questions on this at all? I think we're pretty good. I think we're solid. Yes, you can. And I know Matthew was able to. All right, so 4, 3, 2, 1 on this. Now, we figured out how to determine whether or not something was linear from a table, but what about if we had an equation? Now, this is something that's not in your book, but I decided to add it in just to make sure that you see every aspect from a graph, from a table, and from an equation. Now, to determine whether or not an equation is linear, we're looking for a couple things. 1, it can't have any exponent greater than 1. We know that every number has an invisible exponent. What's that invisible exponent? 1. So we can't have any exponents greater than 1. If we see an exponent greater than 1, that is not a linear equation. Also, you cannot have any equation where the two variables, x and y, are being multiplied by each other. That's not linear. Last but not least, you have to be able to write it in this format. Y equals mx plus b. Notice that the m and the x, what's happening between them? Multiplication. So the slope and the x variable, there has to be multiplication there. If not, that is also not linear. By the way, a single variable, like I said, means that the variables are not multiplied. So we're going to go through these equations. We've got a couple here, we've got a couple on the next slide. We're going to see if we can figure out whether or not they're linear, which means whether or not they meet that criteria. So looking at this first equation here, first thing, do you notice any exponents greater than 1?
No.
No, so it passes that test. 2, are y and x being multiplied by each other?
Yes.
No, they're not. I have y on one side of the equation, I have x on the other. So they're not being multiplied by each other. Passes that one. Last one, is this written in y equals mx plus b format?
Yes.
Yes, it is. Y equals, my slope is 2/3, x plus b. So that means that this is in fact linear. That's linear. Simple.
You opened up something.
Oh, you have a calculator?
I do.
How'd you open?
I have a hidden link in there to prove to you why something would not be linear in case we got to that point. I always have backup plans just in case things go a little crazy. Looking at this one. Let me make sure I get rid of all this. Looking at this one. Is this going to be linear? Yes or no?
No.
Why not, Miss Bacon?
Because it's not in y equals mx.
Perfect. What she's saying is this is not in y equals mx plus b format. Notice m and x. What's happening? What's happening here? Division. This cannot be written in this format. If you were to graph this, you would see very clearly that it's not linear. And I'll explain why. You can tell that from a graph in the next section. But this would be nonlinear, specifically because this is not multiplication. So this would be non-linear. And then Chris, look at that last one. What do you think? Linear or nonlinear? Nonlinear, yes. Why? It has something that it's not supposed to have. What does it have that it's not supposed to have for it to be linear? Remember the first criteria, it cannot have any exponents greater than 1. Do you see an exponent greater than 1 there? Yes, it has an exponent of 2. If there's an exponent greater than 1, that immediately, before we do anything else, makes it non-linear. So this is non-linear. Any questions on these three? Pretty simple. It's pretty straightforward. Just something I want you guys to be able to see. Even though it's not in the book, I want you to see all three sides of a linear relationship. Let's try a couple more. Let's try with some cars now. Let's go to, hey, he's back. Calco! Back from El Hospital, ready to kick some math. writing the equal sign. All right. So, Calco, is this linear or nonlinear? Nonlinear. Why? Because it's an exponent. Good. That is greater than 1. Therefore, this is non-linear. Okay. Good.
Yes.
Come on.
You said it wrong. It's wrong.
We're going to go to the one right here. Is this linear? Yes or no? Okay. Shh. No. Why? Because the y and the x cannot be multiplying by each other. That right there prevents this from being linear. This is non-linear. Good. Okay. I have more. I have a bunch more tickets. Okay. Let's go to rooting. Let's go to this one. Y equals negative x. Is that a linear equation? Yes or no? Let's go through the, yes, okay. Let's go through the criteria. Let's just make sure. You can't even touch this thing. Does it have any exponent greater than 1?
No.
No, it does not. Are the y and the x multiplying by each other?
No.
No, they're not. Is this written in y equals mx plus b format?
Yeah.
I'm going to say it is. Let's examine why. Y equals, what invisible numbers between the negative sign and the x? 1. So I have a slope of negative 1. And if I don't have a number for my y-intercept, that means my y-intercept has to be 0. So technically, yes, this is written in y equals mx plus b format, which means that no exponents, these are not multiplying, and this is written in the correct format, or can be rewritten into that format. That is linear, okay? And then we have one more to go. Let's go to Lauren Vega. Is that linear or nonlinear? Nonlinear, okay? Well, let's examine that. This is an equation. So let's do, hold on, can I actually move this? Yes, I can. Go wait, what? Let's do this. It was 5x plus 4y is equal to 12. Now, let's just go through the criteria. Any exponents greater than 1? No. Are the y and the x being multiplied by each other? No. So you're saying that this is not written or cannot be written in y equals mx plus b format. I'm going to say that we can write this in y equals mx plus b format. Here's what we can do. Remember, what I do on one side of the equation, I must do on the other. So I can rewrite this equation. I can actually do this. I can subtract 5x from both sides. And I'll have 4y is equal to negative 5x plus 12. Now that is not y equals mx plus b format yet, because I cannot have any coefficient next to the y. So what I would do is I divide everything by 4, and then, watch what happens. Y, hey, there's my y, equals negative 5 over 4x. There's my slope, it's negative 5/4. It's next to the x, and then my y-intercept would be, what's 12 divided by 4? 12 divided by 4?
3.
Is 3. So I'm going to say that this one is in fact linear because it satisfies all the criteria. It was kind of a trick question. That's why I saved that one for the end. So don't worry if you didn't get it the first time. Just know that, yes, it is possible to rewrite an equation into the correct format. That cannot be rewritten. That cannot be rewritten. That one could be. Any questions on this at all? Any questions? No? All right. 4, 3. Easy stuff. How many of you know what a straight line is? Come on, are you listening? Are you listening at all? Were you off in your own? Were you on the X-Men world? Come on, the question was, how many of you know what a straight line is? Do you know what a straight line is? Okay. You guys, how many of you know what a curved line is? Okay. Here's the difference between linear and nonlinear. Linear is a straight line. Anything that's a straight line represents a linear relationship. If it's a curved line, it's nonlinear. What do I mean? Now here we don't have a line, but if I were to take a line and connect these points, is that a straight line? Yes or no?
Yeah.
Yes. Well, yeah. Ignore my horrible artistry here. I'll be specific just for you guys. All right. So, is that a straight line?
No, kind of no.
Man, it's a straight line. So that's linear. It does not matter if it's positive or negative. What matters is that it forms a straight line. Doesn't matter if my slope's positive, negative, 0, or undefined. All that matters is if I connect the points, do they form a straight line? So if I connect these points here, if I would connect them correctly, that'd be great. It's a little harder than it looks, guys, trust me. So if I connect these points, is that a straight line?
Yeah.
Yes, it is, which means that that is also linear. Linear is going to be graphed as a straight line. Anything that's linear must be graphed as a straight line. If you go to graph a linear relationship and it's curved, that means that somewhere you made a mistake or you're not graphing a linear relationship. What about this one? Is this one going to be linear, yes or no?
Yes.
Yes. Doesn't matter if the slope is 0, it's a straight line, so that is linear. What about this one? Is this going to be linear, yes or no?
Yes.
Yes. Doesn't matter if the slope is undefined, it's a straight line. That is a linear relationship. Now, linear equation. This, when we get to functions, you'll realize that this is not a linear function. We'll save that for another day. So those are all the linear ones. What about this one down here? Is that going to be a straight line?
No.
It's not, because if I connect these points, notice that it curves, which means that this is a non-linear relationship. Shimon, what about this one? Non-linear. Let's see if we connect all the dots. Line kind of curves up there. Non-linear. Good. Fiamma, what about this one? Louder? Linear. Let's see. We connect the points here. Now visually, usually you can visually inspect it. If I connect the points here, you're right, it is a straight line. This is linear. Now what do you think you can do? And by the way, it's constant at -2, which means the slope here is -2. What could you do if you're unsure whether or not it's linear? What could you do?
Just find the constant rate of change.
You could find the constant rate of change. You could find all of these coordinate pairs and find the rate of change between them. If it's constant, it's linear. If it's not constant, it's non-linear. So if you're ever unsure, if it's not an obvious curve or an obvious straight line, simply find the rate of change between the points. If it's constant, linear. Non-constant, non-linear. Yes?
Can you just use the slope formula?
That's what we did that's what we did before, right? The constant rate of change is the slope formula, yeah. You would write this coordinate pair. This coordinate pair would be 3, 14, and this one would be 6, 10. Is that 5?
Yeah.
5, 10, sorry, 5, 10. You would find the rate of change there, and then you would compare this one and this one. And you see if the rate of change is constant. And you come to find out that it is constant at -2. Okay? Any questions on this? We're going to try a couple more. Any questions? No? Pretty simple. It's visual. Let's go to, what do I do with those things? Let's go to, Sydney. Is this linear or non-linear? It's linear. Let's see if I connect the points. She's right. It's a straight line. That's linear. Chris, is linear or non-linear? Non-linear. Let's see if we connect the points. It's kind of a curve, so it's non-linear. Jennifer Gutierrez, bottom left. What do you think? Non-linear. Good. Because it's curved. Alicia? Bottom right. What do you think? Where is it? Linear because it is a... Why is it linear? Oh, why is it linear from a graph? What about this line tells you that it's linear? Let's back up here. If it's a linear relationship, the points form a straight line. So let's look here. Is this a straight line? Yes or no? Yes, so it is. Oh, I can't hear you back there. So it is indeed linear. Any questions on this at all?
Nope.
No? All right. So, do that, and then, yes, and then it was you, Craig. Yeah. Yeah. Yes. All right. So 4, 3, 2, 1 on this then.
Okay.
I don't know. All right. What's up?
Like, can a line ever be like curve? Can it curve? And then, like both points go or still in the graph.
What do you mean?
So it can a line curve in the graph?
Can a line curve? A line can curve any which way. You have a graph like this. Lines can do just about everything. This is known as a parabola. Upward facing. This is known as a downward facing parabola. They can go like that as well. The lines could also, if you were to graph, by the way, if you were to graph this, y equals 1x. If you were to graph this, actually graph it, here's what it would look like. it would actually form two different lines. If you don't believe me, go Google this. Graph y equals 1 divided by x. Yeah, you can. You'd see it's two different lines. Now, are either of those lines straight?
No.
No, and there's two different lines, obviously. That's why this is nonlinear. Now, if you were to do plus 9 here, that would change the graph a little bit more. But once again, if you want to see how it would change it, simply Google. Google has a tool. If you put in this formula, it'll graph it for you. If you want to see what this looks like y equals 3x plus 7, simply type this into Google. It'll graph it for you. It'll show you the graph of that line. But anyway, I digress. All right, so we've done this before. We have. The only difference is now I took away your line. You don't have a line here. What you have is 3 points. And you're being asked to write an equation in slope-intercept form. The good thing about a graph before is that we were given the what whenever we had a graph?
The line.
We always knew something when we had a graph. What were we always given just by looking at the graph? We were given the y-intercept when we were looking at a graph. Now, because I've taken the line away, you don't know what the y-intercept is. The good thing is that I did not already teach you a way to find the y-intercept. If you know the slope and you know a coordinate pair, can you find a y-intercept? Yes, you can. So let's just go in and let's go through the process. Now, before you want to try to write an equation for any line, you want to determine whether or not it's linear. Because if it's non-linear, you're not going to be writing an equation for it. You're just not. We're going to be writing an equation only for linear relationships. So looking at this, first step, is this relationship linear? Yes or no?
Yes.
Yes. It's a straight line, so yes, it's linear. Since it is, now let's go through the process. We need to identify 2 sets of coordinate pairs. To do that, I'm going to go to my homie, Mr. Tavares. Pick any 2. You can pick that one, or that one. Give me the coordinate pairs. What do you got? Okay, what do you got?
4,
4, 4. Okay, there's 1.
and 8, 16.
And 8, 16. Good. So we have our coordinate pairs. Now we want to find the slopes. So let's go to
Yes.
Tell me, what am I writing my slope form at? I would assume you already know what the y2 and x2 is. Just tell me the slope form.
16
16
minus 4,
minus 4 over.
8 minus 4.
Good. 16 minus 4 over 8 minus 4. And that's going to give you 12 over 4, which simplifies down to, what is my slope? 3. Okay. Then let me ask you guys a question. If I know the slope and a coordinate pair, can I find the y-intercept, Chris?
Yes.
Yes, I can. So, Chris, I have my equation, y equals mx plus b. I know that the slope is 3. I know I'm trying to find b. What coordinate pair do you want to use to help us find the y-intercept?
5, 10, 8, 4, 4.
We just need one coordinate pair. Which one? 4, 4? Okay, so he wants to use 4, 4. We just need one pair. 4, 4. So what's going to go here? Makes it simple. 4. What goes here? 4. And just don't forget this is multiplication, folks. So 4 is equal to, what's 3 times 4? 12 plus b. I now subtract 12 from both sides. These will cancel. And my b is going to be equal to what, class? Negative 8. I have my slope. I have my y-intercept. Everybody understand how we found the y-intercept? Yes or no?
Yes.
By now we should all know how to do that. And then Shimon, what's my equation? My equation? Yeah. Stuck. All right. Y equals, okay.
Y equals y equals
What's your slope?
3
X
x plus 8, negative 8,
plus negative 8, or you could just write
negative
negative 8. Okay, good. Y equals 3x minus 8. Any questions on this? Any questions? No? No? Okay. Everyone have this written in?
Yeah.
All right. We're not going to solve these two, but let's just see if they're even worth solving. Looking at the first one, because I know you guys are going to do this. Looking at the first one, ask yourself a question. Can you write an equation for this, yes or no?
Yes.
Yes, because it is
Linear.
Yes, I can. This is all you need to write. Yes, it's linear. I can write an equation for that. If you actually want to write the equation, it would be something. What'd you have? Anybody already go ahead and do this? What'd you get?
Y equals negative 2x minus 8.
Y equals negative 2x minus 8. Anybody else? I agree with the slope. I don't know if I agree with the y-intercept. Plus 8. I don't know if I agree with that because plus 8's right here. And minus 8 would be down here. It doesn't look like the line's going to go through there. So, let's just examine this. Whoa, hold on.
16 or 17? 17 or 18.
This thing disappeared. Yes. Linear.
Why is your blue dot thing on the bottom?
We have y equals, we have the slope, right? I'll agree with that. And then, what'd you have for the y-intercept?
20.
20. Let's see here. Minus 2, 14. Let's just see here. Let's plug this in. We know that the m is -2. We'll use maybe this coordinate pair here, 6 and 7. 7 and 6. And this is going to be -12. 7, what's the opposite of -12?
Positive.
Positive 12, positive 12, positive 12, which means that my B would be,
Isn't the 6 the y?
oh, I reversed it. Okay, so I reversed it. Hold on. See what happens when you don't write the coordinate pairs? 7, comma, 6. And then we have 6 is equal to -2, 7 plus B, and yeah, that would be 20. Good job. Good job. Y was -2x plus 20, in case you wanted to go and solve it. And yes, I'll give her a ticket for that, and I'll give Viviana a ticket for pointing out.
But it also tells you to write an equation.
It also does tell you to write an equation, but I realized that in first period that everyone already knew how to do that, so I just decided to ask you guys whether or not it was linear. So I always change the lessons as I go, depending on whether or not I'm just sitting here like, you know, doing redundant work over and over. You ever get like a worksheet that's like 50 of the exact same problem, just with different numbers? If you can do the first 2 or 3, can't you do the rest of them? So I figured if you guys already knew how to do this, for the most part, and we've been doing this forever, that would probably just ask you if this one was linear. But now this one, is this one linear?
No.
So can you write an equation here, yes or no?
No.
No, I cannot. Nope. Non-linear. Any questions? Any questions? Any questions? Any questions? No? All right, so we'll be done here. That's going to be 4, 3, 2, 1. This is